Section 8.8, Ohm's Law. So potential difference is what drives the motion of electrons in a circuit. And that motion of electrons in a circuit generates a current, and that current is slowed down by the resistance of the material that the current is flowing through. That resistance is related to the number of available electrons, the size of the wire, the type of material that it is. But when you put all of this together, you get a relationship that's known as Ohm's Law. And Ohm's Law basically just says the current in a circuit is equal to the voltage or the potential difference across the circuit divided by the resistance of the circuit. In general, the resistance of a circuit doesn't change unless something like the temperature changes or the physical structure of the circuit itself changes. So what Ohm's Law just means is that if the potential difference goes up, the current goes up, assuming that the resistance stays constant. So although the resistance in a circuit might stay the same, the resistance of something like a human being can change drastically depending on the situation. And if a human being is then exposed to a potential difference, you can experience an electric shock. Electric shocks just occur whenever a current passes through your body. The resistance of the human body can vary from about 100 ohms to about 500,000 ohms, depending on the circumstances. If you're standing outside on a dry day and you're completely dry and all of your clothes are dry, that kind of thing, then you likely have a relatively high resistance. If you're wet or standing on some material that's wet or standing in a puddle of water, then you likely have a very low resistance. This is why people who experience electric shocks in a bathtub or something like that are much more likely to experience bad outcomes from those electric shocks than those who are just doing something and accidentally electrocute themselves. Now, an electric shock's not going to occur unless there's a potential difference. You've seen this with birds or, at my house, squirrels on the power lines. As they run along the power lines, they're not electrocuted. But that's because the lines themselves have the same potential. The potential difference occurs between the line and the ground. And so if the bird was somehow touching the line and the ground at the same time, it would then be shocked. It only takes a small amount of current to have a bad effect on the body. So even just 1 milliamp of current, so 0.001 amps, you can feel it. At about 5 milliamps, it's painful. The plugs in your wall can deliver as much current as they want to, so long as there's no resistance to stop them. So for example, most of you have a circuit breaker in your house. That circuit breaker is there so that if the object plugged into one of your plugs pulls too much current, the circuit breaker will trip. Those breakers are generally set around 10 to 20 amps. Usually they're 20 amps in residential homes, which means that output could pull up to 20 amps of current before the breaker will flip off. 5 milliamps is just a tiny, tiny fraction of that. And so the wrong interaction with a plug in your home can not only be painful, but it can kill you. At 10 milliamps, you'll experience involuntary muscle spasms. If you've ever accidentally electrocuted yourself, you've likely felt this. It's very uncomfortable and can last for hours. At 15 milliamps, you can lose total control of all of your muscles. And then if you're exposed to 70 milliamps for longer than a second, it can kill you. This is why it's extremely important to be careful when you're dealing with electricity in your home or anywhere else, because your body has no natural circuit breaker. Your body can pull as much current as it can pull at the time.